Hi everyone, welcome to our video on finding the equation of a tangent line where we have an expression involving implicit differentiation. Alright, so it's still pretty much the same process when you have to find the equation of a tangent line, but the only kind of thing that changes is we do our derivative differently. Alright, so, and notice on this, sometimes the point's already given, so that means we can kind of skip a step. Alright, so that's excellent. Otherwise, still find the point. Alright, so the process that we usually do, I'm going to say step one is let's go ahead and get the derivative. So that means we need to find dy dx. Alright, and our equation, so we have x plus, let's go ahead and rewrite that as x to the 1/2 over y equals 18. Sometimes they might want to check to see, does this point actually work? So if I plug 16 in for x, so 16, and actually let's just leave that as the square root and divide by the 2 there. Does that equal 18? Yes, it does. Okay, so sometimes they might want you to verify that the point is a point. Notice 16, square root of 16 is 4, over 2 would be 2, 16 plus 2 is 18. Okay, so that's why it works. Okay, so this point does work, so sometimes they might say to verify, and that's all you have to do. All right, but back to the main part, we want to find the derivative. Well, notice that this portion is a quotient, so that means we need to do the quotient rule. All right, well, no big deal. Let's break it down, and let's go ahead and show it in blue that I'm now doing the derivative. So the derivative of x would be 1, and then we have plus. Now, the derivative of this, we're just going to state it in words, the high d low, low d high minus high d low. Okay, so we've got low, which is the y, low d high, so the derivative of the high would be 1/2 x to the negative 1/2. So there's low d high, minus my high, which is x to the 1/2, times the derivative of the low, which would be 1 times dy dx. Remember, again, if you do the derivative of a y part, attach dy dx. And then all over our low, so y squared, like that. And then equal to 18th's derivative is 0. All right, so that's that. Okay, so this took a while to get this whole thing, but it's looking good. All right, now I've got this big expression. Now, often you don't actually have to find dy dx. At this point, okay, so what we're going to do, I'm going to say part B of 1b. So that was 1a, just get the derivative. Let's plug in, and that looks kind of like 16. Let's plug in x equals 16 and y equals 2, and then get dy dx. And then find dy dx. Usually that's easier in these types of problems. Okay, so let's go ahead and do that. So we've got 1 plus big fraction. Whoops, let me draw that fraction bar straighter. Okay, so I've got, well, sort of. Okay, so 1 plus, and then the y we're saying is 2 times, I saw that as a plus, oops, 2, and then parentheses, 1/2. X is 16, so 16 to the negative 1/2 minus 16 to the 1/2, and then 1 times dy dx. I don't really need to show the 1. Let's just write dy dx all over y squared, which would be 2 getting squared, set equal to 0. Okay, so we plugged it all in, and then this way we can now start to simplify. All right, so I have 1 plus this big old fraction. All right, I have the 2. I'm going to use some highlighter. The 2 and the 1/2 would just multiply each other out. So that means I really just have to simplify the 16 to the negative 1/2. Well, I'm going to do that, so I'm just kind of highlighting it in blue. Let's just put that scratch work up here. Remember, 16 to the negative 1/2 would be 1 over 16 to the positive 1/2. And remember, the half power is the same thing as the square root. So this is all just 1/4. Okay, so that whole thing in the blue is just 1/4. And then I have the minus symbol, minus. 16 to the 1/2, we just talked about it, is 4 again. And then dy dx, and then 2 squared is 4, equals 0 there. Okay, so this is what this looks like so far. And then, well, I still want to, I want to solve, I can put it in the red parentheses, I want to solve for this dy dx. Well, however way you think is best to get there is fine, as long as it follows math rules. So I'm going to go ahead and subtract the 1 over now at this point. So then I have this weird fraction. I have 1/4 minus 4 dy dx over 4 equal to -1. Now, I really do have a fraction on the right side as well, -1 divided by 1. And so what I'm going to do is, because I have a big fraction equal to a fraction, I'm going to do cross multiply. This 4, I'm going to multiply across. This 1, if I multiply across, isn't going to change anything on the left. Okay, so that means I have 1/4 still. I have 1/4 minus 4 dy dx equal to this 4 cross multiplied, and I'm left with -4. Okay, so this is what this looks like. Again, my goal is to get dy dx. So now I'm going to subtract the 1/4 on both sides. And when we do this, well, I would have -4. Let's put this, so I might be running out of room. Okay, so those zeroed out, I have the -4 dy dx equal to, if I were to get a common denominator, it would be -17/4. And then our last step is to get dy dx all by itself. So that means I should divide by -4, or you could think of it as the same thing as multiplying by the reciprocal of -4, like that. And then that way my dy dx is now finally by itself equal to, I have a negative and a negative that would just cancel. So it is positive. And then 17 times 1 is 17. 4 times 4 is 16. Okay, so what we just found, I am going to box it. It's not our final answer, but this is imtan. Okay, so this is imtan. Okay, and now that we have our slope, and we already had our point is 16.2. Now we can do our equation of the line. Okay, so step 2, equation of a line is the y minus y1 equal to m times x minus x1, where we have our slope, the imtan, and we have our points. Let me go ahead and write the point. It was 16,2 was the point already. Okay, so I'm going to highlight. There's our slope. That's going to go in for the m. And then our 16,2 are going to go in there and there. Okay, so we have y minus y1, which is 2. So y minus 2 equals our slope of 17/16 times x minus x1, which is 16. And then now if I distribute, we're almost there. We've got y minus 2 equals 17/16 x minus, now 17/16 and the 16 multiply. The 16 in the denominator and the 16 up top would reduce, and we would have just minus 17 left over. Okay, and then now all I have to do is add the 2 on over, and we're done. Add 2. Add 2. Okay, so we finally got it, and I ran out of room. I'm going to put it right on the side. Y is 17/16 x minus 15. Okay, so there we go. Okay, so I didn't, let me fix my box. Okay, so that is our equation of the tangent line through that point. Okay, so notice it's usually tough. This equation was pretty tricky. Okay, so there's probably other ways we could have done it to make it a little easier. Here's a suggestion. So this y, we could have done the product rule instead. We could have done x plus x to the 1/2 times y to the -1 equals 18. And that would have made it a product rule problem. But it still would still take time. Okay, so you are allowed to manipulate things to better suit whatever you think might be better. All right, but that's it. I'm gonna leave it like this, and make sure you feel good about solving these types of equations. All right, so if you do have questions, let me know. Otherwise, we have another example, but I'm gonna do it in a different video. So we'll catch you there. All right, thanks for watching, and I'll see you again next time.